All right. Hello, everyone. Welcome to day three, phase one of our Python course. For this lesson, we're going to be going over functions. And if we have some time towards the end, we're going to start to go a little bit into how classes work as well. Before we do get started, however, we want to go over the previous assignment from last week, assignment 2, just to go over kind of the implementation for that and one of the ways that we kind of implemented that particular project. So I'll let Scott go ahead and take over for that.
Yeah, thanks, Sahas.
Mhm.
Yeah, so if you don't remember, last assignment was basically making a Mad Libs game on your own. And there are multiple implementations of it. Ours was we could basically read in a string which has a bunch of different blanks and different types of blanks. So basically, if you had a blank that was labeled as an adjective, it would tell the user, okay, print out and type in an adjective for me to insert into this story. And you do that for the entire story until there are no more blank spaces. So we'll just be doing a really short story. You can make this as long as you want in when you turn it in. But for now, we'll just have once upon a time, there was a, and then let's do an adjective. And then noun, so we can describe something that, or a person that lived in, and then a certain city, right? And so let's print that out just to see what that looks like for now, right? So this is just a regular string, and it basically prints out all of the blank spaces that we wanted. Now, what we're going to do is we're going to want to find all of the square brackets, basically until or while there are any square brackets left, we're going to replace anything that's inside of them. Right. So what we're going to do is we're going to do a while loop, and we're going to run it until something happens. So we're going to break it at a certain point. Right. And we're going to have a starting position and an ending position where we're going to replace certain characters. So basically that would be our left and right square brackets respectively. So start pause equals, and then we're going to have end pause equals. And remember, we're tabbing. And for start pause, we're going to have, we're going to take in story, and we're going to use the find function to look for a certain character. In this case, for a start position, we're going to find our left bracket, and the same thing for the end position, we're going to look for a right bracket. And remember that if there isn't that certain character in the string, basically if there isn't a start or a open or close bracket, then one of these will be -1 to be exact. So basically that means if one of them's -1, that means we've gotten all the blanks replaced already. So we can just do if start pause equals -1. So that's saying if we're missing a left square bracket, or if end pause equals -1, that's if we're missing a closing square bracket. And notice how we can do both of these conditional statements in one because we're using or. So this means if at least one of these is true, then we go inside of the if statement. And once we get the if statement, we just break out of it because there's nothing else to replace at that point, right? And otherwise, so we don't have to put an else here. We could, but we don't have to, because if this goes through, then it automatically leaves the loop. But if it doesn't, we just move on. So, so this is going to be check if we've replaced all brackets. And after that, we're going to do, we're going to get an input from the user, right? So we're going to get the word type that we want. So this is going to be an adjective or a verb. So we're going to get, we're going to use our story, and we're going to get pause 1 + 1. Basically, it'll get the character that's right after the square bracket. So like the A in adjective or the first N in noun. And this is going to be start pause. plus 1. And then we're going to go all the way to end pause. Notice how we don't do plus 1 because that would include the right bracket. Okay. And once we do that, we can just get an input from the user. So word equals, and we're going to get an input from the user, and we're going to get the word type, and we're going to add a colon just so that it looks a little nicer. And that's going to let our user type in the word that they want. So if there's an adjective, it would just have adjective right here and a colon. And then we would replace that basically, right? So we would have story equals, and we want basically the entire story from the beginning. So that's why we have nothing before this colon right here, and then all the way to pause 1 or to start pause. And then we want to add the word in between plus the rest of the string. So story from end pause plus 1 and then all the way to the end. So this means that we used a colon and we don't put anything after it. And that'll run until there are no more square brackets, right? And let's see if that works. So we want an adjective. So let's say smart. A smart girl lived in, let's say, Los Angeles. Awesome. And yeah, and you see how we have the words that we replaced, and there are no square brackets left, and there's no formatting error. So this is an example of what you could do. And obviously you could have it output something a little bit nicer for the user to print to look at. So please enter a, right, and it would look a little nicer. Green fox lived in Oregon, let's say, right? And that's basically how you you do it one way for assignment 2. So if there's any questions, let us know in the chat or come to office hours. Otherwise, I think we're ready to go on to today's content.
Yeah, thank you very much, Scott. So, yeah, once again, before we do get started, if anyone has any questions about assignment 2, please go ahead and drop them in the chat, and we'll periodically be kind of maybe answering any question in the chat. But we are going to start getting ready to start with our lesson plan for today, which is going over how to do functions in Python. So before we really do dive into functions, let's first figure out why we would want to use functions in the first place. So let's first create an implementation where we want to print out all of the items in a dictionary. So why don't we go ahead and start off by creating a dictionary of, let's just go with name. So first name as the key, last name as our value. So that's going to go ahead and create a dictionary for those items. And for those of you who were there at the beginning of our class, we were kind of going over different ways to print items from a dictionary. So we're going to kind of use a similar toolkit for that. So yeah, there we go. We have some items in our dictionary. And if we wanted to say print out all the last names of our dictionary, we can create a for loop that goes through each item of our dictionary by its keys and uses that key to kind of get the last name and print that out. So let's go ahead and try that out. Yep. We're going to also include the keys function, otherwise we won't be able to get the last names to be stored into item. So what this for loop will do is it'll go through each key, store that into our variable item. So the first time our loop runs, it'll store the first name Scott and into the variable item. So then when we try to use name square brackets item, it'll be doing name square brackets Scott, which means it'll go through our dictionary, find an item that has a key called Scott, and then we just print out the value it's storing, which in this case it's vo. And it just keeps doing this for each item in our list until we get to the very end, or in our dictionary. Now, if we added a new item into our dictionary, so after our for loop runs, we wanted to maybe add a new item into our list, into our dictionary. So let's go ahead and add maybe, let's go with, yeah, Stephen Dong. So we're going to have a key for Stephen and then a key value Dong. And then if we want to print out the list again, well, we're going to have to rerun our for loop. So I'm going to just include all of that stuff that we did earlier one more time. And that way, we will, when we run it, it'll update and also include Stephen's last name into our list. Now, this is a bit tedious because we need to constantly be kind of re-implementing and placing that set of for loop every time we update our dictionary. We'll come back to how we can kind of adapt this piece of code so that it'll better fit what we need it to be for. Instead, now what we're going to do is we're going to transition into functions and what functions really do in Python. So some of these things that we've already been using in previous assignments and previous codes were actually functions. For example, the print function. How the print function works is you write the name of the function, a set of parentheses after that, and you provided some information for it to do something with it. In this case, it takes a string and it'll print it to the terminal. Now, there's a lot of different types of functions in Python that are already available to you, but what if you wanted to create your own custom function? Well, in order to create your own function, you want to use the keyword def. That lets you define a new function. And what kind of functions really do in Python and in all programming languages is it will usually typically take in something as an input and then it'll manipulate that, do something with that information, and then it'll provide you an output. That is typically what a function can do. There are some special cases where sometimes you don't need to include an input, and sometimes there are special cases where there might not be an output. But typically, it's going to be a input goes in, something happens, and then an output comes out. So in the case with this function that Scott just put together, he defined a function called print hello. And notice how he put parentheses after print hello. The reason why we put parentheses after a function name is if you don't put parentheses after a function name, Python will think that it is a variable instead. And since we use variables to store information, it's not really ideal to have an item that's storing information also being used to simultaneously manipulate other information. So we use functions instead for that. So yeah, we have our function name and then a set of parentheses and then we have a colon following that. The same reason why we use colon for if statements and for loops applies here, where now everything that is tabbed inside of our print hello function is kind of a part of that print hello function. It'll only run when that particular function is what we refer to as called, which is just another fancy way of saying that we are telling that function to run. We're calling the function. So then on line 27, when we call the function print hello and run it, it'll print out the text hello world. Or sorry, in this case, it prints out hi, my bad. But yeah, so any questions on defining functions and also how to call the function? All right, well, now that we have a little bit more context with how we can create our own functions, why don't we revisit our dictionary problem that we are looking at earlier, where every time we try to input a new item into our dictionary, we had to rewrite our for loop to kind of print out all of the new items that have been added to our dictionary. So instead of having to run that for loop or copy and paste that for loop wherever it's needed multiple times, we can instead place it into a function and call the function instead. So how do we do that? Well, let's just go to the very top of our code because how Python runs and looks at code is it does it sequentially line by line. So we first need to define how a function works before we can actually use it. So typically all your function definitions should be at the very top of your program, and then you start to pile in all of the code that uses those functions that you've built. Now, we're defining a function that'll help us print the last names in a dictionary. So we typically want to have an appropriate name that will associate with the function so it's easily understood what it does. So in this case, we'll just say print full name. Now, what Scott is doing here is he's including something called a pass, or he's including some sort of input for our function to work with. But instead of calling them inputs, because they might mix up with the actual input function, we'll be referring to them as parameters, a parameter for a function, which basically refers to anything that gets modified or inputted into our function for our function to basically work with. So what we basically did is define a function called print full name and provided a parameter called input dict. Input dict will expect a dictionary and print out all the items in that dictionary. And notice how, one more time, we have a colon at the end. So all of our text will be part of our print full, anything that's tabbed in will be part of our print full name function. So we're testing something real quick. We want to test out if we can reprint out our input dict. So we're going to go ahead and call our function. And another notice how we're not redefining the function. We're not writing def at the beginning anymore. We already defined what the function does earlier. Now we're just using what the instructions for that function is on line 13. So we have print full name, and then we provide our function with the proper parameter. And in this case, what Scott went ahead and did was he manually took the parameter input dict and assigned it names. This is really nice to have whenever you want to specifically tell which parameter you want to modify. For those of you who remember, with print functions, there was a parameter that we modified, which was the end keyword. So the same thing is happening here, where instead of modifying end and setting it equal to something, we're modifying input dict and assigning it names. So now when we go ahead and run this program and run this particular function, it should print out our dictionary one more time. So there we go. Now what we can do is take our for loop that we made earlier and place that into this function. So whenever we want to print out all of the names in our dictionary, instead of having to copy paste our function, our for loop multiple times in our code, we can instead just call print full name. So Scott will go ahead and modify that. And what we're doing is we're concatenating item, which will contain our first name. We're doing a string concatenation with the last name, which we get from the dictionary. So when we go ahead and run this, the print full name function we will no longer need the for loops at all. We can just run the print full name function and provide it the proper parameter. And when we go ahead and hit run, we should expect all of the names to print out with the appropriate first and last name being kind of in that string that we expect to print out. And that is a whole lot easier and really nicer to look at than just running the for loop multiple times whenever we need it. We can just call the function print full name instead. Yeah, so it saves a lot of space. All right. So as we're another kind of topic related to functions is how we can use it for modifying data in general. So we're going to start to move away from our dictionary example. Before we do, any questions on our dictionary example and how we utilize the print full name function? I'll give you guys a second to kind of think about that and see if there's any questions, and we'll move on. All right. Well, if there's no questions, let's go ahead and move on. So why don't we first create a simple function that will take in a number and add the number 5 to it. Oh, we have a question from Richard. He wants to go ahead and see the function again. So let's go back to the function. So I can quickly kind of go over how this function works one more time. So we're using the keyword def to define a function. The function is called print full name, and we provided a input dictionary variable as its parameter. So whatever gets passed into the function will get stored into input dict as the variable. Then we will be using that variable for the rest of that function. So on line 4, we have a for loop that will say for item in input dict.keys. So input dict.keys will provide all the keys in our dictionary and store that into into item one by one as our for loop is running. And then we just have a simple print statement that'll print the key and then find the appropriate last name that's associated with that key. Yeah. Do you still need a second, Richard, or do you got it? All right, cool. So let's go ahead and move on from that example. We want to now, let's say we want to define a function that will take in a number and add, let's say, 5 to the value. So it'll take in an integer and adds 5 to it. So for starters, we need to provide an input for this particular variable, sorry, for this particular function. So we'll create a parameter called user input. Now we want to add 5 to our value. So let's create a new variable. We can call that, let's go ahead and call that temp num, our temporary number, and assign that what we get when we take user input and add 5 to that. So I'll just be user input, arithmetic plus sign, and the integer 5. And then there's two different things we can do here. First, let's start with what we're all used to, which is just printing that out to the terminal. So after we get our variable, we want to just print out our temp num. So whenever we use our add5 function, so let's go ahead and use the add5 function and provide it a number, let's say, yeah, let's say 3. So what we'll expect to happen when we hit run is the integer number value 3 will get stored into the parameter user input. Notice how this time Scott just manually put in the number instead of doing user input equals 3. Both would work. You can just add the variable or item into the parameter just as is, and it'll work the same way. Uh, and yeah, they both produce the same value, 8. So, so the number 3 gets stored into user input. We do user input plus 5, so 3 plus 5, which is 8, and store that into temp num, and then we print out temp num. So that is one implementation that we are all kind of familiar with of course, a function twist to it. Now, if we want to instead kind of be able to store that value, the temp num value, outside of the add5 function, because let's say instead we had before we did add5 3, let's say 3 was stored into a different variable, like let's just create a variable called num and set equal to 3. And then let's use the add5 function. Oh, Brian has a question. Could you do add5 input enter a number? I don't believe we can have function calls inside of a parameter. Parameters are specifically for storing variables or storing information that we'll be using later on. Do you want to go ahead and test it out, Scott, just in case?
Yeah, sure. I think it might work. However, even if it does, I would recommend against it, as it would probably be a little messy to read. So let's say we wanted to do add5, and then one thing that we have to remember to do here is, since we're doing math, we need to cast it to a number. So we're going to cast our input into a string, sorry, into an integer here. Yep, and that should be good. Yep. And it actually works. However, even in this fairly simple code, it does look a little jumbled. So while it does work, I would recommend a little bit against it. Yeah, good question though.
Cool. That was something that I wasn't actually aware of that you could do, where you can just call a function inside of a function. But I guess we learn something new every day about Python.
Yeah, it all
Um,
depends on how the functions work and how they return, which is actually something we're going to be going over in a second.
right. So what we just covered was we can take a variable, in this case num, and set equal to 3, and then run it through our add5 function. So let's go ahead and do that real quick. So instead of add5 on just the value 3, we're going to pass in our variable num. So whatever num is storing will also be stored into user input, and then we hit run. And that'll produce the same value 8. But let's try printing out what num is storing after we do the add5 function. So we expect it to store the number 8. But let's see what actually ends up happening instead. So we print out the number 8 from our add5 function, but the variable num is still equal to 3. That's because we never modified what num is equal to. We can even do that on line 37, where we can, instead of storing it into a new variable called temp num, we can say we can store it back into user input. That's completely valid still. And let's go ahead and hit run. So we still get the number 8, but num never gets modified to equal what the new value is after we added 5 to it. Now, the reason why that's happening is we kind of created a copy of the integer 3 and stored that into user input. And then whatever we modify for user input will never directly affect the variable num. Now, if you do want to store the result that comes from add5, we instead use the keyword return, which is used for returning any kind of variable or integer or any kind of value from a function that has been produced by that function. So we can instead return user input. And let's go ahead and try running that as is, just to see what happens. So right now we just get new val equals 3. That's because return isn't actually used for printing to the terminal. What it does instead is it'll take the value that is in user input and return that to where that function was called. And if you just have a function being called without anything to kind of capture or store what the return is, returning, it'll kind of just throw it into the abyss and you will basically never see that data ever again. So instead what you want to do is you want to kind of capture that information back into a variable so you can use that information later on in your code. So what we can do on line 44 is say num equals and then the add5 function. This way, whenever we print out our new val, it'll take whatever went into our add5 function with the value 5 added to it, and when it returns that, it'll store that back into num. So now we can kind of see the pipeline for that. So our old value was 3. Then we run it through our add5 function. It returns the new value, which is 8, and we store that back into num. And then we print out the new variable num. And since it's been modified by the add5 function, it'll now print out the value 8. So any questions on the return function and how we use that in Python or in functions? We have a question. Are there pointers or references in Python? Well, good question. So actually, this rule will really only apply for stuff like integers and floats. Say we had a list instead. So let's create a brand new function that will maybe add like a new item to a list. So we can just create a function real quick, just called append5. And it'll take in a list or an array. And for those of you who aren't into like CS or C++, an array is basically just another type of list. It's like a list, but with very kind of nerfed down characteristics. But in this case, we're just going to treat them as regular lists or as vectors, if you guys know what vectors are. Now, so we're going to define a new function called append5, which takes in a list and appends the value 5 to it. So Scott went ahead and created a variable called user array that stores 4 different integers. And now we're going to run the append5 on that and then immediately print out user array. So we're going to get the before and after for those. And then when we go ahead and hit run, we can see that in this case, whenever we took our list and passed that into append5 and then added the value 5 to it, it's going to add 5 to that value, and it kind of does the thing by pass by reference, where it'll take instead of taking a copy of our list, it's going to actually just be storing the exact same content that user array is, and whatever modifications happen to that list will kind of carry through. So it's kind of different from how integers are treated. A quick question: has my internet been sounding kind of choppy to you guys by any chance? At the moment, okay, cool. So, all right. Let's see. So that was how we can kind of modify stuff by, so what this refers to, this example is called pass by reference, where we basically refer to the same set of items, no matter if we passed into a function. So we're not making a copy, what we refer to as a deep copy of the list. We're doing something called a shallow copy, which is instead having the variable array store the same items that user array is. So any modifications that happen to array will also carry on to user array. Yeah. Another topic to kind of cover over functions are default parameters. So let's say that the user wants to use a function, but maybe they don't want to, they don't necessarily need to modify or add a parameter to the function, but we still need some kind of a parameter for that function to work. So let's say, let's refer back to our add5 function. Let's say they want to do add5 function, but they don't include a parameter for it. Well, we can use a default parameter so the function won't break and kind of use that default value instead of whatever the user input is. So the way we do that is instead of just doing user input, we then have it assigned to a default value. In this case, a default value of 0. And then we'll just do the same thing that we did earlier, which is return user input plus 5. So we're using the plus equals shortcut in this case, which will just increase user input by 5, and then we'll go ahead and return that. Or actually, in this case, just to keep it short, let's just print it out. So that'll just save us a few lines of code. But typically, if you want to recapture that data, you'd want to return it instead. So now let's just run the add5 function. And this time, let's not put anything inside the parentheses and see what happens. So in this case, since we didn't provide a parameter for the add5 function, it'll use the default value of 0 instead. So it just does 0 plus 5, stores that back into user input, and prints that out. Now, if you do provide a parameter, like in this case, the second time we use the function, we provide the number 3, it'll prioritize whatever the user passed into the function call instead of the default parameter. So in this case, it'll do 3 plus 5 and gives us 8. All right. So let's see. The next topic that we want to kind of go over is kind of clarifying the function calls with keyword arguments. So, oh, actually, sorry, we already kind of covered that, but just as a recap, let's say we had 2 different inputs into a function. So let's create a quick, why don't we create like a quick add function? So like adding 2 different variables together. And we'll have a variable A and a variable B. So let's say we wanted to just add those variables together and print them out. So we'll create a print for A plus B. And let's also create some default params just in case. So we'll set A to 0 and B to 0. So let's say if we wanted to, let's say we just wanted to modify the variable B. So typically if we did, if we wanted to add 2 variables like 5 and 3, so we do 5 comma 3, that will work perfectly fine. That'll produce us the number 8. But let's say we only wanted to modify the variable B. Now we could, so let's just try doing, in this case, no matter what we do, we're going to get the same value because A and B are both equal to 0. So let's say the default parameter for A is 3 instead, just to get some differences in here. So on line 69, Scott, could you maybe change the default parameter of A to 3? Yeah. So what we're going to do is if we just pass in the value 3, I'm going to just expect the value 3 to be printed out from the add vars because we're just modifying A to be equal to 3 and B will take in the default value 0. So 3 plus 0 will produce 3. Now, if we wanted to modify just the parameter B, we just do B equals 3. So that means we're directly affecting the parameter B to be set equal to 3, and we're kind of skipping over A. So A will keep its default variable, and we're modifying the B variable instead. Or sorry, B parameter instead. All right, so let's go ahead and test that out. And looks like it works. So we are able to instead effectively change the parameter b to b3 instead of taking its default value. So that's just how we can kind of clarify function calls by using its keywords in the parameter. Now for this next part, I'm going to have Scott kind of take over, and we're going to go into how we can organize properly how all of our functions kind of run. So we can write code much more cleaner. So Scott, the floor is yours.
Yep. Thanks, Sahas.
Mhm.
Yeah. So as you've noticed, we have been racking up quite a few function definitions, and that's fine for now. We're not doing anything too complicated, but once you start developing more complicated programs, it's nice to stay more organized. So one thing that a lot of people do is kind of separate functions into different files. So if you look on the left side of the screen, we actually have a utils.py file. And I've already actually written a function here. So this is basically in the case that I need to print lists very often, and I don't really want to write it over and over, but I also don't want this kind of auxiliary function to mess up my code in my regular code or in my main code. This is where you could define our function. And what we do to call that function, since it's in a different file, we can't necessarily do print list. It actually says it's not defined because Python doesn't know that we're using that file. So what we can do is, just like how we did with assignment 1, where we imported random, we can actually import our own file as if it was our own library. So we can do import utils. And here you can just, you could do the exact same thing with random. You could do as, I've seen some people do U or capital U, it's all up to you. But right now, I think I'm okay with typing utils over and over. And from here, we can actually just do something like, so what utils does is it takes in a list and it prints out the list in a certain format. So what we do is let's have our list. So x equals 1, 2, or actually, let's do hello world. And notice how I can put lists in multiple lines because Python knows that these square brackets are encapsulating the list. And in this case, it knows that like it's usually a little easier to see things if you have to write a lot into a list. So this is just a personal preference thing. You can choose to do it in one line if you wanted to, so long as you have everything within those square brackets. How are you? And I think that's enough. And we're gonna do utils dot. And if you notice on VS Code, it actually looks into the utils file and says, okay, I found a function called print list. So this is really, really convenient. And if you pass in an X, right, we're basically saying, okay, from the utils file, we want to print the list. And what we're passing in or telling it what to print is the list X. So once we print that out, it'll print out our code with a special format. Now, this is really good in terms of organization, but what if you wanted to test the utils function? Well, the print list function. Well, I could put this exact code into the utils.py, but notice, oh, and we don't need the utils here since it's in the same folder, but notice if we run the code here, it actually happens twice. Oh. Yeah, so it actually happens twice. And that's because when we import the utils code, it actually runs everything inside of the script. So something that we have to do is tell Python to only run this code if I'm running it directly. So basically, the only time I'm going to be running the extra code in utils is when I'm running only utils or when I'm debugging or trying to fix utils. So what we can do is do something called if name equals main. And notice how there are 2 underscores on each side of both name and main. And main is a string. And for those of you using C++, this is kind of similar to the main function. However, it is a little bit different because you can put this in multiple different files. And once I save, if I go back to day 3, you can actually see that it only prints out one time now. And this is really useful because we can, oops, wrong file. We can do whatever we want here, and it'll only run if I run it directly. So here I'm on the utils.py file, and we're going to be running that. And let's change up the list just to make sure that we have everything. So let's just do hi, my oops, name is Scott. And if we print that, we had that hi, my name is Scott, only because we ran utils directly. So this is a really useful debugging tool if you're making different files. And again, if I run this, even though we are importing utils, since at this point our main file isn't utils, it's not going to run the stuff that's inside of if name equals main, right? So going back to here, if I run this, it'll just say, hello world, how are you? And that's basically how the if name equals main thing happens. And general practice is to do that in whatever files you're doing, especially the main file. So if this is the main Python script that we're using, which has most of our heavy lifting code, then we would still have if name equals main. Can you have both files open next to each other? Yes, you can actually. So if you have Windows, this is just like window snapping. If you're on Mac, this is something that you can do with Windows. So if I grab the tab of the window that I'm looking at and I just drag it to the left, you see how it's a little brighter on the left side. So you can actually drag that over there, and everything else could be put to the right. Otherwise, you can drag from the left side, or you could drag across the windows and everything like that. And you can look at both codes at the same time. Yeah, that's a great question. This is very useful if you're working on a lot of different code at once, especially if you're working on different files at once. Yeah, and once again, if we run utils, it's not going to run anything in the day 3 code, right? And I think that's everything for the if name equals main. Yeah, it's just the main thing is to remember to have this exact formatting. This is one of the things in Python which really requires really precise formatting, because it's looking for a really that specific string of characters in your code. And is utils a PI file? Oh, yes. So that's really important. Make sure that utils is a Python script and it's in the same directory, or it's the same folder. Yeah, and I think that's everything in terms of the name equals main function. Is there anything else that I missed, Sahas?
No, I think you covered all of it. We do have a question from Richard though. He's wondering why his utils can't be imported. Do you want? Is there any like specifics that that's happening on your end, Richard, that you want to kind of clarify? As another
Yeah,
thing that could have maybe. Oh, sorry. Go ahead.
yeah. So it's just having a yellow line under the utils. That's the error saying like module not found.
Do you have
Sorry, go ahead,
just to make sure, do you have utils on like on the left side of your screen? Did you make a new file?
Oh, no, I didn't. I think I may have skipped over that. Like, what do I do?
Yeah. So you'll just make another Python script. So this is basically making a new file that you can store your code in, and this is for custom code. So you can put whatever you want into the utils file, and you can name it whatever you want, and then you just import it as if it was some other library.
Okay. I see.
Right. So I think that should be everything in terms of the main functions, right?
Yeah, I think so.
All right, cool. So we only have about 10 minutes of kind of class time left. So I want to spend the remainder of class kind of going over a few function examples, and a few of them might be helpful for the next assignment as well. So why don't we go ahead and start off with a kind of simple one. So why don't we create a function that can convert, let's say, Celsius to Fahrenheit? How would we build a function like that? And at this point, I'd like to maybe have some participation from the audience. So if we wanted to define a function that can go from Celsius to Fahrenheit, right now Scott went ahead and built a very default function definition. So what should we first include for our function definition before we go along and kind of edit how the function works? And you can go ahead and either open your open mic, or you can just go ahead and text it in the Zoom chat. Yeah, so Scott's kind of giving a bit of a hint. It should be something inside of our parentheses. So what can we include in the parentheses that'll kind of help us with defining our Celsius to Fahrenheit function? All right, we'll need a parameter that'll help us initialize the Celsius value. So why don't we go ahead and create a variable called Celsius temp. And now what we want to do is define what our function will do, which is basically we want to convert from Celsius to Fahrenheit. So that's going to require the Celsius to Fahrenheit conversion equation. Now, I don't know if any of you have that handy, but I'll give you guys a few seconds to see if you can get that in the chat. Otherwise, we'll just go ahead and give you guys the conversion, because I don't think it's something that a lot of people have memorized. All right. Well, if we want to convert from Celsius to Fahrenheit, we want to use the equation, which is 9 divided by 5 times the temperature plus 32. So we're going to create a variable called Fahrenheit and set it to that particular equation. So we're going to do Celsius temp times 9 divided by 5, and then we just add 32 to the end of it, and then we can return the Fahrenheit value. So we go ahead and test this function out. Let's go ahead and print out Celsius to Fahrenheit and provide the parameter. Let's try 96 degrees Celsius. Oh, sorry, 98 degrees Celsius. All right, let's try it. Yeah. Let's go ahead and test that out. And we get 208.4 degrees Fahrenheit. So looks like our conversion, I think it's working. I need a cross-reference for that, but I think it sounds about right. Yeah, looks good. All right. Yeah, why don't we try 0 degrees Celsius just to be sure? All right, yeah, we got 32 degrees Fahrenheit for that. Cool. So if we wanted to do kind of the opposite for that, so a Fahrenheit to Celsius, kind of the same deal. Make sure whenever you're creating function definitions, we have underscores that are kind of combining all of the text for the function name. If you have spaces, I'll kind of treat them as either separate variables or separate functions, and we'll have like a whole other kind of mess. But yeah, same deal. We'll have Fahrenheit temp, and we want to just do the reverse equation. So we're going to say Celsius equals. Now here, instead of doing Celsius equals, let's do a shortcut. Instead of storing it into another variable, we can directly return an equation instead. So we can say return Fahrenheit temp minus 32. So that should actually be in parentheses. And then we just multiply that by 5/9. So let's go ahead and try that out. And yeah, we get 0 degrees Celsius for that. All right. Now we're going to quickly go over some examples that might be helpful for our assignment 3, which will be due next week before class. So the first thing that we're going to do is, hopefully we can get this all done, is let's start with a summation function. So we're going to kind of recreate the summation equation or summation symbol from math that'll basically add values from a certain amount to another. We're going to create a more simplified version of it where we just default start at the value 0 and go up to whatever the parameter is. So for that, we're going to define a function called sum, and we'll require a parameter for whatever number we're kind of stopping at. So we'll say sum parentheses, or yeah, sum parentheses num.
Yeah, sorry, Sahas. Just to interrupt really quickly.
Mhm.
One thing that to watch out for when you're naming functions is also to make sure that the name of the function doesn't already exist,
Oh, right.
which is really easy to fall into. So in this case, sum's actually already a function that takes in a list and adds all the elements.
So let's go ahead and instead call it summation instead. And we'll provide it a variable or a parameter num. Or yeah, max num is also fine. And then we're going to create a kind of simple, yeah, we can use for loops. In this case, I actually want to use a while loop just to kind of experiment with what we can do with other kinds of loops. So we're going to create an algorithm where we start with, before we start our while loop, we're going to declare some variables. We want to create a variable called total sum and set that equal to 0. And then we want to create a current num, so kind of our counter, and set that equal to 0 as well. So now we're going to create a while loop that'll run as long as our current number is less than or equal to the number that was passed in as a parameter for summation. So we'll just say current num is less than or equal to, and so we can just do the less than symbol and equal symbol together to get effectively a less than or equal to, and we'll check if that's less than or equal to num. Now what we want to do is increase our total sum by our current number that we're at. So we use the plus equals for incrementing, and then we also want to increment our current num to the next number value. So we'll just do current num plus equals 1. Now this loop will continue running until our current num exceeds the value of the num that was passed in as a parameter for summation. So we can just go ahead and return total sum at the end. All right, so let's go ahead and test this program out. So we're going to print out our summation, and let's give it the number 3. So it should do 1 plus 2 plus 3, which gives us 6. So in this case, we get the number 6. So that means our function is working fine. So yeah, that was the implementation of our summation function, and I think that'll help you guys a bit with trying to figure out how you can create an algorithm for solving our assignment 3 problems. Now, we only have about 3 minutes left, so I want to kind of start getting our class wrapped up for the day. So were there any questions that you guys might have had that you didn't have a chance to ask yet? Please go ahead and place that into the chat. Yeah, so as we're getting any maybe last minute questions, I'll start to wrap up. So that was everything for our phase 1 day 3 Python course. Oh, we got a question. Could you please re-explain utils and the if name? Scott, do you want to go ahead and take that one?
Yeah, sure. Those are actually both of the things I explained today. So, so the utils is kind of just putting your code into different folders to keep it organized. So if you've taken a computer science class before, it could be for different different types of functions that you're using, or you could do even storing different data. In this case, we have a utils.py, which is utilities, and we've actually user defined this file that we can import into our other files. And this lets us keep these functions away from our main code, and that lets us keep things more organized while still being able to use this code. Because this code is pretty important. However, we don't need to see how print list is implemented every time. We kind of just need to use print list. So what we do is we make a new file called utils.py. You can name it anything.py as long as there aren't any overlaps in the naming. And from there, we just define our functions. So we have print list, you can have our add5 from earlier. And once you save that, you can import the file. Excuse me. You can import the file and the file name dot whatever function that you're using. And then at that point, you can use it just as if it was a regular function. Right. And that works for every file that's in your in that folder. So for example, if I had pre-class, it would actually allow me to use that too. So if I did import utils, it actually recognizes utils and lets us import it. Okay. Yeah, so and that kind of ties into our if name equals main situation. So let's say we wanted to test out utils, basically test out the code that we've defined in here. We could just type it out here, print whatever. But the thing that happens is when we import it, all the code actually runs. So what we do to combat that is we put that if name equals main, and the stuff inside of this code only runs if you're running utils directly, right? So if I ran our day 3 code, it would not run the stuff that's inside of the if name equals main for utils. And yeah, that's just a brief explanation. We are out of time. So if you're still confused, I'd recommend coming to office hours. That goes for anyone who's having trouble with the assignment or is confused on any of the content. But yeah, I'll just turn it back over to Sahas to close up.
Yeah, thank you very much, Scott. So as Scott said, office hours are open. So we have Scott's that's on Monday, and mine will be on Wednesday. The timestamps are on the Discord. So if you guys have any questions, do please feel free to drop in and ask. We won't bite, we swear. We're just here to help you guys learn Python. But yeah, so that kind of concludes our day 3 of the Phase 1 Python course. I hope everyone enjoyed today's lesson and learned a bit about how to use functions in Python. I think it's very, very useful tool because a lot of Python is built off of using other people's function definitions and stuff. It's really powerful stuff. But yeah, that should cover everything for today. So I'll go ahead and end the recording for today, and I'll linger around a little bit for any last minute questions. But yeah, thanks for coming, everyone.